I can now live forever.
Have you ever paused to truly consider how incredibly young human civilization actually is? Or, how absolutely dramatically our world has transformed in just the last century or so? It's the thought that can genuinely, rearrange your whole perception of time, can't it? Welcome to the Deep Dive. Today our mission is to journey through a fascinating collection of sources exploring the evolution of human civilization. We're looking at its surprisingly recent origins, right up to a future that honestly could be utterly unrecognizable to us. We're going to pull out the most important insights, some really surprising facts, and hopefully help you grasp this incredible sweep of human progress. It's propelled by, big environmental shifts, but also our own accelerating understanding of the universe, ourselves, and the powerful machines we've created. Let's jump in. So maybe to start us off, when our sources talk about human civilization, what exactly do they mean? It's not just any group of people living together right now.
Precisely. That's a key distinction. The sources define human civilization not just as early communities, but as the emergence of really complex societies. We're talking about a specific package deal, kind of. You need things like centralized governance, you need large urban settlements.
Cities, yeah.
Cities, exactly. Clear social structures, hierarchies, widespread agriculture is fundamental. Then writing systems and the use of increasingly advanced technologies. It's that whole tapestry woven together.
And here's where it gets, a bit mind-bending for me. Because if that's our definition, then true human civilization only kicked off roughly 5,500 years ago. I mean, think about that. Homo sapiens, our species, has been around for approximately 300,000 years. So this entire span of what we call civilization, it's this tiny, tiny fraction, less than 2% of our total time on Earth. It's like barely a blink.
It really is just a brief blip in deep time. And when we look at where this story starts, the sources point to a few independent cradles of civilization, places where it popped up on its own. And they all seem to emerge around a similar time frame, roughly the 4th millennium BCE.
All right, okay. So we're talking about Mesopotamia, modern-day Iraq, often cited as the earliest, maybe 3,300 to 3,800 BCE, with cities like Uruk, early writing.
That's the one often pointed to as the oldest, yeah. About 5,500 to 6,000 years ago from today. Then you have ancient Egypt forming along the Nile, maybe 3,200 to 3,500 BCE, becoming unified shortly after.
And what's striking is completely separately over in Peru.
Exactly. Norte Chico, the Carl Supe civilization, developed around 3,100, 3,200 BCE, remarkable for its large-scale communal architecture. It's the oldest we know of in the Americas.
Wow.
And then you also see independence starts in the Indus Valley in modern Pakistan and India, ancient China along its great rivers, and the Olmec in Mesoamerica, who influenced later cultures like the Maya, each unfolding over the next 1,000 years or so.
Okay, so this raises the big question. If we humans had modern brains, modern cognitive abilities for basically all those 300,000 years, why the incredibly long wait? Why were we nomadic foragers for nearly 290,000 years before civilization finally took root?
It's a great question, and the sources suggest a few key reasons. Firstly, for most of that immense period, the hunter-gatherer lifestyle was actually incredibly sustainable for small groups.
It worked?
It worked. It required minimal social complexity. Resources were often sufficient without needing intensive farming or storing massive amounts of food. But crucially, the climate was a major factor. Harsh and fluctuating conditions, especially during the last glacial period, the Ice Age, which only ended around 12,000 years ago, that severely limited opportunities for settled agriculture.
Right, unstable weather, huge ice sheets, not exactly ideal for planting crops and staying put.
Definitely not. So even though we see signs of behavioral modernity, advanced tools, art, symbolic thought appearing maybe 70,000, 60,000 years ago.
It didn't immediately spark complex societies.
No. Knowledge was likely contained within these small mobile bands. And critically, without agricultural surpluses, you just don't have the capacity for specialized roles. No full-time artisans or administrators or priests.
Everyone's basically focused on getting the next meal.
Pretty much. And this ties into something some sources call the sapient paradox, or the gossip trap hypothesis.
Okay, what's that?
Well, imagine trying to build up hierarchies or concentrate power in a small, tight-knit band where everyone knows everyone else's business intimately. These social leveling mechanisms, enforced by constant interaction, you could call it gossip, might have actively prevented the kind of leadership structures and inequalities needed for larger societies to form. It kept things egalitarian, perhaps too much so for state formation.
Like social pressure keeping anyone from getting too powerful.
Sort of, yeah. And on top of that, you have the simple fact that widespread writing systems didn't really exist until much later, around 5,000 years ago. Without writing, large-scale record keeping, managing complex trade, administering laws across big populations, it's incredibly difficult, if not impossible.
That makes sense. It's fascinating. So, okay, then why the seemingly sudden emergence? And
Yeah.
why did it happen independently in multiple, often isolated places around the same time? It feels like a switch just slipped.
It does feel like that, but the sources suggest it wasn't truly abrupt. It was more like a parallel response to profound global environmental shifts. The big one was the end of the last ice age and the beginning of the Holocene epoch. This brought a period of much warmer and, critically, much more stable climates worldwide.
Stability. That's the key.
It seems to be. This new stability allowed for the independent invention, or perhaps rediscovery and refinement, of agriculture in these particularly fertile cradles, usually river valleys offering reliable water, rich soils, maybe some natural protection.
Like the Tigris, Euphrates, the Nile, the Indus, the Yellow River.
Exactly, those places. Perfect spots for settling down. And once you have reliable agriculture, you get food surpluses.
Which means you can support more people.
Right, population booms. And not everyone needs to farm anymore, so you get division of labor artisans, soldiers, administrators, priests.
Which leads directly to cities, centralized governments, and eventually the need for writing to manage it all.
Precisely. And what's really insightful, according to the sources, is that this happening around the same time across different hemispheres, even in isolated places like the Americas, wasn't necessarily about ideas spreading. It wasn't cultural diffusion, initially.
So what was it?
It seems to stem from shared global environmental pressures and opportunities. The climate becoming stable enough was a global phenomenon, or perhaps localized pressures like droughts forced groups to settle near reliable water sources like rivers, independently pushing them towards agriculture.
So it's like universal human ingenuity kicking in when the conditions finally allowed for it. Similar problems, similar solutions.
That's a great way to put it. It highlights how adaptable we are when the environment changes.
That transition is incredible. Okay, now let's fast forward quite a bit. If environmental shifts were the big catalyst for early civilization, what about the last, say, 125 years? From 1900 to today, it feels like a completely different kind of acceleration driven by understanding itself.
It absolutely is a different engine,
does.
you know? In just over a century, our fundamental grasp of the universe, of matter, of systems, it's profoundly transformed everything. Take cosmology and relativity, just realizing the sheer size of the observable universe, 93 billion light years across, and expanding. That came from Edwin Hubble's work in 1929. It just shattered our old perspective.
It blew the doors off the old view of our place in the cosmos.
Completely. And then you have Einstein, special relativity in 1905, giving us seesaw, redefining space-time energy. Then general relativity in 1915, explaining gravity not as a force, but as the curvature of space-time itself.
The impact there is just immense, isn't it? It's not just theoretical.
Not at all. It dismantled anthropocentric views for sure, but it also directly enables technologies we use every day, like GPS navigation. Your phone's GPS has to account for relativistic effects to be accurate.
Wow, I didn't realize that.
Yeah. And of course, it fueled the ambition for space exploration. The moon landing in '69 is a direct descendant of that shift in understanding. Then you dive into the very small, the quantum realm. Quantum mechanics really formalized in the 1920s by folks like Heisenberg, Schrödinger, building on Bohr's earlier model. It revealed this bizarre, probabilistic world beneath classical physics.
Which sounds super abstract, but led to something very concrete.
Incredibly concrete. That fundamental understanding led directly to the invention of the transistor in 1947 by Bardeen, Breton, and Shockley.
And the transistor.
Yeah.
Well, that changes everything. That's the birth of the digital age.
Exactly. Suddenly you have the path to computers, then microchips, smartphones, the internet, transforming information, economies. Silicon Valley exists because of quantum mechanics, fundamentally, and how we interact globally.
And we can't forget nuclear physics.
Absolutely not. Nuclear fission, understood in 1938, the quest for controlled fusion starting around 1951. This harnessed the power within the atom itself, leading to nuclear power, which, provides around 10% of global electricity today, but also, tragically, atomic weapons, which completely reshaped geopolitics, especially during the Cold War.
So massive shifts in understanding the physical world. What about abstract systems?
Huge leaps there, too. Think about game theory, introduced by von Neumann and Morgenstern in 1944. It gave us tools to mathematically model strategic interactions.
Which influences economics, diplomacy, even AI strategy now, right?
Definitely. Then there's chaos and complexity theory. Edward Lorenz's work in the 60s, the famous butterfly effect, it helped us understand how seemingly small changes can lead to huge, unpredictable outcomes in complex systems like weather or financial markets. It didn't make things perfectly predictable, but it vastly improved forecasting.
And information theory. Claude Shannon, 1948.
Foundational. Shannon figured out how to actually quantify information transmission entropy. This underpins pretty much all digital communication, data compression, cryptography, how the internet itself functions. It enabled the information explosion we live with.
For better and for worse sometimes, with misinformation.
That's the double-edged sword, absolutely.
And the engineering that came out of all this.
Equally striking. Radar really demonstrated effectively in 1935. The jet airplane, first flown in 1939. These completely revolutionized warfare, yes, but also civilian air travel, safety, making the world feel much smaller.
Global travel became a reality for many.
And rockets. Robert Goddard's early liquid-fueled rockets in the 1920s evolved into the massive engines that took us to space, starting with Sputnik in 1957. That lineage gives us satellites for GPS, weather forecasting, global communications, broadband internet, plus ongoing missions to Mars, pushing frontiers, driving STEM education, sparking international collaborations.
So looking back at that 125-year period, the overall impact.
It's just transformative. These advancements, overwhelmingly post-1900, dramatically extended human capabilities, boosted life expectancy worldwide, supercharged productivity, and connected billions of people in ways that were pure science fiction before. It marks an era of accelerated progress unlike anything in prior human history. Though, as you said, it absolutely came with new challenges, new complexities.
It's fascinating how understanding the external world reshaped things so profoundly. But what about the inner frontier? Understanding ourselves, the human mind. Psychology and psychiatry have also changed massively since 1900, haven't they? We understand things like clinical depression, bipolar disorder, personality disorders so much better now. I mean, you mentioned standardized diagnostics. They didn't even exist back then.
Absolutely right. If you look back at 1900, understanding mental health was, well, rudimentary is putting it kindly. It was often based on speculative theories, like Freud's early work, or just vague terms like insanity. Treatments were limited, often harsh, like in asylums, with very little grasp of underlying biology.
And a world away from today.
A world away. Today, thanks to standardized diagnostics and huge leaps in neuroscience, our understanding is incomparably deeper, more evidence-based.
And the DSM, the Diagnostic and Statistical Manual of Mental Disorders, seems central to that shift. The first one wasn't until 1952.
That's right. And while early versions existed, the real game changer, according to many sources, was DSM-3 in 1980.
Why was DSM-3 so revolutionary?
Because it moved the field away from subjective interpretations and towards objective, observable, symptom-based criteria. It tried to make diagnosing mental disorders more like diagnosing physical illnesses based on a clear checklist of symptoms. This was huge. For instance, it clearly distinguished unipolar depression from bipolar disorder based on the presence or absence of manic or hypomanic episodes. That was a major clarification.
Okay, so it brought structure and empiricism.
Exactly. And later editions, like DSM-5 in 2013 and its update in 2022, have continued to refine this, moving towards more nuanced, dimensional approaches for some conditions, consolidating others like the autism spectrum, and importantly, reframing terms like changing gender identity disorder to reduce stigma.
And this better classification helped drive other discoveries, like understanding brain chemistry.
Directly. Understanding depression better paved the way for realizing the role of neurotransmitters like serotonin, which led straight to the development of SSRI antidepressants in the 1980s. Understanding bipolar disorder's episodic nature helped recognize hypomania better and guided the use of mood stabilizers.
And for things like personality disorders, borderline, narcissistic.
The clustered approach in the DSM helped group symptoms and behaviors, informing the development of specific targeted therapies like dialectical behavior therapy, DBT, which has been very effective for borderline personality disorder.
That diagnostic revolution is one piece. The other seems to be actually seeing the brain at work. Brain imaging, fMRI, PET scans.
Absolutely transformative. Functional MRI, really taking off in the 1990s, lets us see brain activity in real time. PET scans, developed earlier in the 70s, can show metabolic processes, receptor density. These tools opened up the black box.
So what specific insights have they given us? For depression, for example.
For depression, fMRI studies often show patterns like hypoactivity, less activity in parts of the prefrontal cortex involved in planning and emotion regulation, and hyperactivity in the amygdala, the brain's fear center. We also see disruptions in what's called the default mode network, the DMN, which seems to correlate with the kind of inward-focused rumination common in depression. PET scans have even pointed to inflammation as a factor in some cases and can sometimes help predict who will respond best to SSRIs.
Well, and for bipolar disorder.
Again, fMRI reveals altered patterns, like changes in amygdala activation during mood episodes and issues with frontal lobe regulation. Interestingly, PET and SPECT scans have sometimes linked bipolar symptoms to underlying infections or inflammation, things like herpes or toxoplasma, which in some specific cases can point towards non-psychiatric treatments alongside traditional ones.
Fascinating. And for personality or identity disorders, can imaging help there too?
It's starting to. Research has shown structural differences, like potentially reduced volume in areas like the hippocampus and borderline personality disorder. Functional anomalies are also being studied in identity-related conditions. The big picture here is that these tools provide potential objective biomarkers. They move us beyond relying solely on patient self-reports. They can help differentiate between disorders, predict treatment response, maybe even uncover specific biological subtypes of these conditions. It's still developing, and there are ethical considerations, but it's powerful.
So pulling this thread together, this huge leap in understanding ourselves, what's the ultimate impact?
I think the biggest impact is the integration of psychology with biology. It's led to truly effective, evidence-based treatments, therapies like cognitive behavioral therapy, CBT, refined since the 60s, and much better use of medications like mood stabilizers, understanding lithium better since the 70s. It's profoundly humanized mental health, moving it from being seen as a moral failing or a mysterious curse to being understood as a complex interplay of biology, psychology, and environment, a treatable aspect of the human condition. Challenges definitely remain, like relapse rates and access to care, but it's a monumental shift.
Absolutely monumental. Okay, let's shift gears one more time. We've talked environment, understanding the universe, understanding ourselves. Now let's look at the sheer muscle behind modern civilization machines. Our sources make this really compelling case that over the last 300 years or so, say 1725 to 2025, harnessing machine power has made our world almost unrecognizable to someone from 1700. I mean, picturing the world of 1700, it was overwhelmingly agrarian, wasn't it?
Yeah.
Power came from muscles.
Almost entirely. Human and animal muscle power did the vast majority of work. You had some limited mechanical aids like water mills or windmills, but that was about it. Life expectancy globally was maybe 35, 40 years. The entire planet had fewer than 700 million people. It was a world defined by intense manual labor, highly localized economies, and incredibly slow communication and travel.
Then came the Industrial Revolutions, bang. First one, late 18th century. Steam power.
Steam engines, yeah. Suddenly you have locomotives like Stephenson's rocket in 1829, steamships, mechanized mining, and factories. This was the fundamental shift away from feudal and agrarian economies towards industrial ones.
It snowballed, right? Second Industrial Revolution, late 19th century.
Right. Now you've got widespread use of fossil fuels, coal, then oil. Electricity becomes practical. Steel production gets cheaper and more efficient. This leads to continent-spanning railroads, massive steel ships, even early submarines, and the assembly line changing manufacturing forever.
And the 20th century just put that on steroids.
Totally. The internal combustion engine powers cars, trucks, buses, but also tractors and combined harvesters that revolutionized agriculture, allowing us to feed billions. Heavy machinery, bulldozers, cranes reshaped the physical landscape, making skyscrapers possible. Aviation went from flimsy biplanes to global jetliners, even specialized things like crop dusters.
And the communication explosion alongside it.
Astounding. From the telegraph being the fastest thing, you get radio widely adopted in the 1920s, television booms in the 1950s, and then the internet takes off from the 1990s onward. Information, news, entertainment suddenly global and near instantaneous.
So if you put 1700 and 2025 side by side, the contrast is just stark. Transportation, horse carts and sailing ships versus jets, high-speed rail, global shipping networks.
Agriculture, manual plowing, maybe an ox, subsistence farming versus GPS-guided tractors, combines drones, GMOs feeding 8 billion.
Construction. Hand tools, buildings maybe a few stories high versus giant cranes, bulldozers, 3D printing skyscrapers, automated factories.
Energy. Muscle, wood, wind, water versus fossil fuels, nuclear renewables, powering continent-wide grids.
Communication. Word of mouth, letters by courier, maybe a printed book versus smartphones, streaming, VR, AI writing news articles.
Daily life itself. Predominantly rural, labor-intensive, high mortality versus increasingly urban, automated conveniences, longer education, leisure time, a globalized economy.
What's the core insight here about the impact of machines?
The core insight is that they multiplied human capability. They don't just assist, they amplified our power dramatically. Global GDP per capita exploded, maybe over tenfold since 1700. Populations urbanized from maybe 10% living in cities to over half today. Lifespans nearly doubled globally. Machines connected the world. They freed many humans from backbreaking physical toil, enabling education, science, arts on a wider scale. But like any powerful tool, they also brought downsides. Environmental degradation, pollution, the horrifying efficiency of mechanized warfare.
So machines have radically amplified our physical capabilities. But there's one frontier you could say they haven't really crossed yet, thinking like humans. I mean, computers have processed information for, nearly 80 years, since ENIAC in 1945. But processing data, even complex analysis, isn't the same as genuine novel thought, creativity, understanding. Our sources suggest this might be the next big threshold with artificial superintelligence or ASI.
Yes, that's a crucial distinction. Current AI, even the most advanced large language models, are essentially incredibly sophisticated pattern matching and data synthesis engines. They don't understand in the human sense. They don't generate truly original insights from scratch. Artificial superintelligence, however, is the hypothetical next step, an AI that doesn't just match human intelligence in specific tasks, but fundamentally surpasses it across virtually all domains. Creativity, complex problem-solving, scientific discovery, even social and ethical reasoning.
And the timeline for this, some experts think, soon.
Predictions vary wildly, as you'd expect for something so speculative, but many experts anticipate artificial general intelligence, or AGI AI, with human-like cognitive abilities could potentially emerge within the next, say, 2 to 30 years. And ASI, superintelligence, might follow relatively quickly after AGI is achieved, perhaps through recursive self-improvement.
So the parallel the sources draw is that just as mechanizing physical labor transformed civilization during the Industrial Revolutions,
Deploying ASI to mechanize or vastly amplify cognitive labor, creative thinking, problem-solving on a massive scale could transform civilization in equally, if not more, revolutionary ways.
the potential sounds staggering.
It is. Imagine ASI generating breakthroughs in medicine, discovering new physics, designing solutions to climate change, maybe even tackling philosophical paradoxes. At speeds and scales biological minds simply cannot match. Some talk about an intelligence explosion, potentially leading to a post-scarcity era where basic needs are effortlessly met.
But there's a huge but, isn't there?
A monumental but. The sources are clear about the profound risks. The alignment problem, ensuring ASI's goals align with human values, is paramount and incredibly difficult. There are risks of unintended consequences, societal disruption like mass unemployment in knowledge work, or even scenarios where humanity loses control or is fundamentally outcompeted. It's a future with extremely high stakes.
High stakes indeed. Okay, let's push this speculation even further, building on what the sources suggest. They propose a future, maybe just 100 years out, around 2125, that could be truly alien to us today. This isn't just ASI, but the convergence of what they call a tetrad of technologies. ASI plus at least million-qubit quantum computing, plus advanced nanobots, plus highly capable robotics.
Right. The bold prediction layered in some of this material is that this specific combination could produce a civilization by, say, 2125 that is as profoundly strange and unrecognizable to someone from our time, the early 2000s, as our world would seem to someone teleported from 1700.
And the logic is that the 1700-2000 transformation was about mechanizing muscle.
Whereas 2000 onwards is about mechanizing cognition and manipulating matter at the nanoscale. That shift, the sources argue, leads to potentially exponential acceleration.
Okay, let's quickly break down this tetrad and how they might synergize. ASI, we've discussed the orchestrator, the superthinker.
Then you add 1 million qubit quantum computing. Current systems are maybe around 1,000 qubits, give or take, but the trajectory is steep. IBM targets 10,000 soonish. 1 million qubits is seen as potentially feasible for complex simulations, maybe by the early 2030s, maybe broad use by 2040.
And what does that unlock, especially combined with ASI?
It unlocks the ability to tackle computational problems that are simply impossible for classical computers, even supercomputers. Think simulating complex molecules perfectly for drug discovery, designing entirely new materials with desired properties, optimizing vast global systems like energy grids or supply chains in real time. ASI could leverage quantum power for breakthroughs, and quantum computing could accelerate ASI's own development.
Okay, so supercognition meets supercomputation. Then nanobots. We hear about early stuff now, like drug delivery, but scaled up.
Scaled up and potentially self-replicating under ASI control, nanotechnology could enable true molecular manufacturing. Imagine desktop factories that can build almost anything: food, tools, complex devices, atom by atom from basic raw materials. It could also mean radical human augmentation. Nanobots patrolling our bloodstream, repairing cells, potentially leading to indefinite lifespans, or interfacing directly with our neurons for brain-computer links, enhanced senses, maybe even shared consciousness. And on a planetary scale, swarms of nanobots could potentially remediate pollution or even help terraform other planets.
Mind-boggling. Now the fourth piece, advanced robotics. We see humanoids getting better now.
Combine today's trajectory AI integration, faster learning, better dexterity with the rest of the Tetrad. You could have robots that are incredibly adaptable, perhaps powered by quantum AI for complex tasks, built from self-healing nanotech materials. They could become ubiquitous companions, workers in hazardous environments like deep space mining, extensions of human will operating with incredible precision and autonomy.
So the synergy is key. Quantum AI makes robots smarter, nanobots make them more resilient or able to interface with biology. It's a feedback loop.
Exactly. A recursive self-improvement cycle across all four domains, potentially driven by ASI. That's where the potential for truly explosive change comes from.
So paint the picture, based on the sources. What might this alien and unrecognizable civilization of 2125 actually look like?
Well, speculating based on these synergies, you could genuinely see a post-scarcity economy. ASI quantum systems optimizing global resources perfectly. Nanobots assembling goods on demand. Robots performing essentially all physical and maybe most cognitive labor. Poverty could be eliminated, but the very concept of work and human purpose would be radically challenged.
What about us, humans?
Human augmentation could be commonplace. Nanobots merging with biology for radical life extension, enhanced senses, maybe direct neural links to AI or each other. The line between human and machine could blur significantly. Mind uploading might even become feasible.
And beyond Earth, society.
Robotic swarms could be actively terraforming Mars or other bodies. Quantum simulations might allow us to solve climate change rapidly or manage planetary ecosystems with incredible precision, socially and ethically. It's almost impossible to predict. New forms of governance might be needed, perhaps involving ASI directly in decision-making. We could face utopia, dystopia, or something totally unforeseen.
So the alienness factor, it's not just technological, it's fundamental.
It could be. To someone from our time, imagining things like telepathic communication via brain interfaces, cities that physically reconfigure themselves, or hybrid human-AI consciousness, it would feel as utterly alien and perhaps unbelievable as our world of smartphones, gene editing, and global internet would seem to a farmer from 1700.
And while experts seem cautiously optimistic about AI's benefits in the nearer term, say by 2040.
The full convergence of this tetrad, if it happens, could accelerate things to these far more extreme transformative outcomes, assuming, of course, the immense technical and ethical hurdles can actually be overcome.
Wow, what an absolutely incredible journey we've taken today. From that long, slow dawn of civilization, nudged into existence by subtle shifts in climate, all the way through the hyper-accelerated progress of the last couple of centuries, fueled by our expanding understanding and the incredible power we've unleashed with machines.
It really puts our current moment in a unique context.
It really does. So maybe the final thought to leave everyone with is this. If human civilization was so dramatically reshaped when machines amplified our physical capabilities, and now we're standing on the cusp of machines potentially amplifying our very cognitive essence, what does it truly mean to be human in that unfolding future? What new purposes, what new challenges, what new adventures will we discover when so many of the old ones, scarcity, perhaps even mortality as we know, might just be solved? That's something to ponder.